Let's do this thing, okay? All right, so we've got a system here that we're gonna solve using these augmented matrices. So we've got x plus y plus z equals 3, 2x minus y plus z equals 0, negative 3x plus 5y plus 7z equals 7. Now, we're going to triangulate this matrix in order to solve it. But it's not in matrix form yet. So first thing to do is to get it into matrix form. So that means we're just going to keep all the numbers, drop all the variables. So this first one's going to be 1, 1, 1, 3. That's kind of nice. This one will be 2, negative 1, 1, 0. Remember, you will have zeros in there. And then negative 3, 5, 7, 7. We put the little line down there like that. And there is our augmented matrix. So when triangulating, the idea is that we want to get these three guys, those three, we want them to be equal to 0. And remember that what we can do is we can use the other rows to help us make that 0 with these row operations. So if we wanted to make this 2 a 0, we can use this guy up here, but we need to multiply him by a negative 2. Right, so we're going to go negative 2r1 plus r2 is going to be equal to our new r2. Okay, now, underneath, I would show some scratch work. So negative 2 all the way through. So it's going to be negative 2, negative 2, negative 2, negative 6. That one's not so bad. Now this guy stays the same. 2, negative 1, 1, 0. And when we combine, those guys are going to give us a 0. This is going to be negative 3. This is going to be negative 1. And that's going to be negative 6. So when we write our new matrix, the first row we're not changing. So the first row stays 1, 1, 1, 1, 3. The last row doesn't change. Negative 3, 5, 7, 7. But now that middle row is our new scratch work here. So it's 0, negative 3, negative 1, negative 6. Line down here and close it up there. So we've got 1, 0, and we're working on these two now. So let's go with this one. It's always easiest to just go from top to bottom, and so dink, 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 okay? So this guy, we can still use this first equation, but we need the negative 3 to disappear, so we need that to be a positive 3. So this time, when we write our arrow, we're gonna take 3 R1s plus R3, and that's going to be our new R3. And I'm going to see if I can smash it in here just so we have a little extra space. All right, here we go. So 3 R1s. So 3, 3, 3, 9. Multiply all the way through. And now we're dealing with this guy. We're leaving him alone. Negative 3, 5, 7, 7. Okay, so the nice thing is that these guys go away and leave us a 0. This is now an 8. This is now a 10. And that's now a 16. Okay, it's not looking all that pretty, but we can also do something else. All of these guys have a 2 in common, don't they? So we can divide the whole thing by 2, and I'm going to make a little note up there. We're dividing by 2, and that means it's going to be 0, 4, 5, 8, which at least the numbers are a little bit smaller, a little bit nicer to deal with. Okay, so let's see if I can mush that in here. Top row stays the same, 1, 1, 1, 3. Second row stays the same, 0, negative 3, negative 1, negative 6. This guy becomes our new 0, 4, 5, 8. We need that to be a 0. But we don't want to use this guy up here because that will change our zeros here. So we're just going to be using these two guys in order to change that to a 0. So there's two ways to go about this. One way would be to turn that into a 1. So if we wanted to, we could divide row 2, divide row 2 by 3, okay? But if we do that, we're going to give ourselves, so we could go row 2 divided by 3. All right, well, if we did that, the top row stays the same, 1, 1, 1, 3. But the middle row now becomes, actually let's do negative, so we're getting rid of the negative. Becomes 1, 1/3, 2. Bottom row stays the same, 0, 4, 5, 8. Okay. So now, in order to get rid of a 4, we could multiply this guy by -4. Okay, -4. But if we multiply that by -4, that's not getting any prettier, is it? And all of a sudden, I don't know, this just seems like such a mess. What do you think? Do you guys agree, kind of a mess? We could go on, couldn't we? But what's the point? Why do we want to go on when this is messier than what we were doing in 8.1? I personally feel that it was easier with the X, Y's, and Z's in it. You could see more what was going on. This is just a bunch of numbers all over the place. So what's the point of this? And to be honest, if I was standing here in front of 20 of you, you guys would be looking at me like, why are we doing this? And you're probably sitting at your desk going, why am I doing this? So let's figure out why we're doing this. So I know we're gonna break this lecture into like 3 parts, but let's stop now and figure out why the heck we're doing this, right? And that requires your graphing calculator. So it's time to go find that graphing calculator, and I'll be back with you in part 3 when we will finish this problem.